Hey everyone, and welcome back to HSC Maths Tutoring with Nathan. And today I'm going to show you how to solve trig equations using t formula when they're in this format: a cos x plus b sin x equals c. And let's make a note here: c does not equal 0. If c equals 0, you do not need t formula to solve that. So I'm going to show you step by step how to do it, and we'll start with a simple example: 2 cos x minus 3 sin x equals 1 for 0 to 2 pi. Now, if you stick to the end, I'm also going to go for a bonus t formula proof as requested. So I'm going to prove this equation using t formula. So that will be at the end after this trig equation. So let's get back to this. So the first thing we do is let t equal tan half the angle, right? Because if you look at my last video, when we're using t formula, we let t equal tan of half the biggest angle in the question, so that means in this case it's t equals tan x on 2. And what we need to do now, before we get to the end, so we don't forget, is adjust domain for t. So what that means is if x is between 0 and 2 pi and t is tan x on 2, we need to adjust the domain to match that x on 2, so we just halve everything. So the domain for t we're solving is 0 to pi. So now the next step, the really simple step, sub t formula for sine and cos. So we're just directly going to substitute it in. So cos x, the t formula is always 1 minus t squared on 1 plus t squared, minus 3, and sine is 2t over 1 plus t squared equals 1. Now in all trig equations with using t formula, what we do at this step is we just multiply each term by 1 plus t squared. The reason we do that is it's going to cancel every fraction. It's going to cancel that out, it's going to cancel that out. But don't forget to times it by this, as I said, each term. So now that's going to look like 2 brackets 1 minus t squared minus 3 brackets 2t equals 1 plus t squared, because it's just 1 times that. So then at this point is expand, collect, and put in at squared plus bt plus c equals 0 form. Right, we should be able to write all these in terms of a quadratic in terms of t. Now there is the rare case where it won't be quadratic, but I'll deal with that in a future video. So if we expand, we get 2 minus 2t squared minus 6t equals 1 plus t squared. Now I'm going to bring everything to the right side so that we have a positive t squared. So we get 3t squared plus 6t minus 1 equals 0. So I'm pretty sure the next step is obvious. Solve for t. So if you're smart enough to get to this stage, I'm pretty sure you know how to solve this. Simply, we're just going to use the quadratic formula in this case. Make it straightforward. 6 plus or minus 36 plus 12 over 6. That's minus 6 plus or minus square root 48 over 6. I'm just going to leave it like that. We don't need to simplify because we're solving for x, not t. So those are my t values. So what do I do next? So now that we've got t values, is you sub t for tan x on 2, or what it is from step 1. So t was tan x on 2, so that means tan x on 2 equals negative 6 plus or minus square root 48 over 6. And our domain is x on 2 is between 0 and pi. So now the last step, solve for x. And we can just use a calculator to do this. Use calculator. So there's going to be 2 equations here. We're going to do the plus and the minus. So we do the plus, I'm just going to get the calculator here, tan inverse of negative 6 plus square root 48 over 6. So we get 0.153 to 3 decimal places. And then if I type in the -6 minus, that's going to give me a negative answer. So where's 10 negative? So look what the quadrant is. So we're only in the first and second quadrant, so it's negative in quadrant 2. So quadrant 2 is 180 minus, in this case pi minus 1.136. And all we do to get the answer now is times everything by 2. So x would be 0.306 and 4.011. So those are the answers for x for this equation. So that covers step by step how to solve trig equations using t formula when it's cos plus sine equals a number that's not 0. There is a rare case where you don't get a quadratic in t, and I'm going to cover that in a future video. That deserves a whole video to itself. So now I'm going to go over and do the bonus question. Okay, so if you're stuck here to the end now, as I said at the beginning, I am going to go over and prove this proof using t substitution. So if you watched my last video, the first thing to do is we let t equal tan half of the biggest angle. The biggest angle is x, so we're going to let t equal 10x on 2, which means I can now substitute the t formula in. So 10x is 2t on 1 minus t squared. Cot x, so cot is 1 over tan, and because it's x on 2, and it's just 1 over t. 10x is again 2t on 1 minus t squared, and 10x on 2 is just t by definition. So now if you watch the last video, the next thing we do is we times everything, the trig here, by the lowest common denominator, which is this denominator combined with that denominator. That means we're going to times top and bottom by that, so that, because that will cancel every fraction. So now the left hand side will become 2t squared here, because this 1 minus t cancels with that 1 minus t squared, plus 1 minus t squared, because that t cancels that t, over, same thing here, 2t squared minus t squared brackets 1 minus t squared, because there's no fraction here, so you just times that by that. So now we just clean up the numerator and denominator, collect like terms, t squared plus 1 over 2t squared minus t squared plus t4. Let's clean it up, so the numerator is fine, the denominator is t squared plus t4, which we will notice we can factorize the t squared out, which is now t squared plus 1, crosses that out, which is 1 on t squared, which is finally cot squared x on 2, by definition, as t is 10x on 2, which is the right hand side. So I did this bonus question as I had a special request for this video, and they requested how to do trig equations using t formula and proofs using t formula for x on 2. So I hope you guys enjoyed this video. If you did, make sure to give us a thumbs up and make sure to subscribe for future videos and share with your friends. Also, comment below what you would like for future videos, and I will probably be able to make a video on that. Otherwise, I'll see you next time.